Okay, so this exercise 4.2, question 37. If f of x equals 4 minus 3x divided by 1 minus x, show that f of x is greater than 2, then x cannot take on a value between 1 and 2. So what we have is 4 minus 3x, 1 minus x is greater than 2. Okay, next thing we're going to do is we're going to have to figure a way to cross multiply, get the 1 minus x over the other side. Now because we don't know if 1 minus x is positive or negative, what we need to do is we need to multiply both sides by a positive number. Now the number we always tend to use is the denominator squared, okay? So the denominator squared guarantees that we're multiplying both sides by a positive number. Okay? So what we have here is, if I was to cross multiply the 1 minus x up to the 2, it basically wouldn't work because I wouldn't know if it's a positive or negative number. So what I am going to do is multiply both sides by 1 minus x squared. Now 1 minus x squared will basically mean that the 1 minus x squared is multiplied on both sides. This cancels with the 1 minus x on the left, so the denominator on the left cancels with the squared on the left as well. Then what I'm going to do is multiply out 4 minus 3x by 1 minus x, and what I'll get is 4 minus 4x. 4 minus 4x minus 3x plus 3x squared. That's going to be greater than 2 times. So what we're going to do first is going to multiply out the brackets, okay? So it's going to be 1 minus 2x plus x squared is what 1 minus x squared equals. Now we're going to have to multiply this by 2. So when we multiply it by 2, what we're going to get is 2 minus 4x plus 2x squared. What we need to do is get all the numbers on one side, so we're going to bring everything over to the left. When 2x squared goes from the right to the left, it comes minus 2x squared. 3x squared minus 2x squared is x squared. Then we're going to add the minus 4x and the minus 3x on the left to become minus 7x. The 4x from the right goes onto the left side to become plus 4x. That will give us minus 3x. Okay, and then we have 4 on the left and 2 on the right, so we're going to bring the 2 over the other side. And when we bring the 2 over, it comes minus 2, and this is going to leave us plus 4 minus 2, which is plus 2. This is an example of a graph, a U-shaped graph, because the x squared is positive. We have to figure out the two values for which it crosses the x-axis. We do this by solving the equation normally, and what we're going to get there is x equals 2 and x equals 1. We're next going to draw this U-shaped graph, where it'll have intercepts 1 and 2 respectively, and that's the U-shaped graph to the right. Now please remember, it says greater than 0. This means that I'm looking for when the red line is above the x-axis. Okay, and this equation in the blue blocks represents the U-shaped graph. It represents the y value of the U-shaped graph. So when is this y value greater than 0? So we can see in this shaded blue region, anything smaller than 1, the y value is bigger than it, and anything bigger than 2, it's also shaded in blue, because this means that this line is above the x-axis. So what we're going to do is we're going to get x is greater than 2 and x is less than 1. So x is smaller than 1 but greater than 2. Okay, and then we put it in. So remember, it's greater than, okay? Greater than is what we're looking for this question. Now this means, alright, the fact that it can't exist between 1 and 2. See the way it says cannot take any value between 1 and 2. We're just after proving that x is greater than 2 or x is smaller than 1. This means values between 1 and 2 don't work. X values between 1 and 2 give a y value that's below the x-axis, and this basically means that it doesn't work. This red zone here doesn't work, and that proves what the question was asking us. Okay. So next question is going to be number 38. So I'll just wait for this here. Now what you can also do for the last question is, if you want to test a number between 1 and 2, if you want to see if your answer is correct, okay, if you test a number between 1 and 2, like 1.5, 1.5 shouldn't work. So what we did here was we took our equation and we replaced we took an equation, this equation here, the 4 minus 3x 1 minus x, and it has to be bigger than 2. Replace it with all the 1.5s, And what happens is when you replace it with the 1.5s, so you're going to get 4 minus 3 times 1.5, 1 minus 0.5 greater than 2. What happens is we can figure out minus 1.5, that is 3 minus 4.5 is 0.5 for the numerator, and it's also minus 0.5 for the denominator. 0.5 minus 0.5 divided by minus 0.5 is 1. 1 is not greater than 2, hence we showed that this number does not give a correct answer as it's not bigger than 2. Okay. Now here is number 38, 2x plus 1 divided by x squared plus 5. Now what we need to look at about this one is the x squared plus 5 on the bottom. The x squared plus 5 is guaranteed to be a positive number because x squared, no matter what the value is either going to be 0 or positive. Any number squared is positive. And when we add on 5, it also means that it's going to be positive. So all we got to do for this question is actually just cross multiply. So we're going to find the values of x element r for which f of x is smaller than a half. So what we're going to do here is we're going to just cross multiply the x squared plus 5 up. Now what they're trying to get you to do is this. They're trying to get you to multiply both sides by x squared plus 5 squared. That's if you don't understand it. In the previous question it was something like x minus 3 or 3 minus x, and we didn't know whether it's positive or negative. But in this question, because it's x squared plus 5, we know it's guaranteed to be positive. Also, if you do this method here, you could end up with an x to the power of 4 equation, which most people won't be able to solve. Okay, so let's make this easier on ourselves, and let's just cross multiply the x squared plus 5 and the 2 up. So 2 times 2x plus 1 is 4x plus 2. 1 times x squared plus 5 is x squared plus 5. Next step, bring the 4x and the 2 over the other side, and we're going to get 0 is less than x squared minus 4x. Bring the 2 over the other side, comes minus 2. And what we're going to get is plus 3. Okay, and then we're going to get x squared minus 4x plus 3 is greater than 0. This is what happens when we switch it around. It's the same thing as saying 4 is greater than 2, 2 is less than 4. I'm basically switching around the inequality. Now I'm going to solve this, and to solve this, what I'm going to do is going to get x minus 3. The reference number is plus 3, so it's going to be x minus 3, x minus 1. If I draw this graph, we know that the two answers in question are going to be 1 and 3. It's a U-shaped graph, and what happens is we want it to be bigger than 0. So once again, we're going to be taking it's greater than 0 because it says that. So it's going to be this red line here. So any numbers that are less than 1 is greater than 0, and any numbers that are bigger than 3 is less than 0. Okay, so x is less than 1, x is greater than 0. Okay, I think that's the end of this answer there. Now, if you were to take an answer in between both of these, so we see that it's 1 and 3. Let's take x equals 2 and test it out. If I replace the x here with 2, I'm going to get 2 multiplied with 2 plus 1, which is 5. On the bottom I'm going to get 2 squared plus 5, which is 9. Is 5 over 9 less than a half? Well, 5 over 9 is not less than a half, so we're just after showing that the number 2 doesn't work. And because the number 2 doesn't work, this means that our answer is not in between 1 and 3, it's smaller than 1 or bigger than 3. This is called a term test, okay? So false. Okay. So that's the end of this question here. Alright, next question. 43. A is the set of values of x for which x squared minus 5x plus 6 is less than or equal to 0. B is the set of values for x for which x squared minus 5x plus 4 is greater than or equal to 0. Is there any values that satisfy A intersection B? Justify your answer. A intersection B means the answers of A combined with the answer of B. Which answers are in both sets? So we're going to do what we've done the last couple of times. We're going to do the reference number, and we're going to figure out that it's x minus 3, x minus 2. We're then going to draw our U-shaped graph. And when we draw our U-shaped graph, we're going to get x equals 2 and 3. Now, this time, once again, it's greater than. And if it's greater than, it means it's this shaded black region in there and the shaded region to the right. This means x is less than 2 and x is bigger than 3. Okay, just skip the next part. There. Okay. oh sorry, this is it here guys, so x minus 2, x minus 3 is just what I did a second ago, equals x equals 2, x equals 3. Then we draw the u-shaped graph like last time, and it's, this time, if you excuse me guys, this is actually the question, I didn't write it down right the first time, it's actually less than or equal to 0. So what we're going to do is we're going to solve x squared minus 5x plus 6 is less than or equal to 0, x minus 2, x minus 3 is less than or equal to 0. So we just solve that and we get 2 and 3. But this time we want to be less than or equal to 0. So it's the shaded part in between, because this is when the y value is lower than the x axis, okay? So we're going to have, it's the in-between value, okay? So it's going to be 2 is smaller than x is smaller than 3. Next part we're going to solve is x squared minus 5x plus 4. Okay? And what we get here is x squared minus 5x plus 4 greater than equal to 0. We're going to get x minus 1, x minus 4 greater than equal to 0. This is a greater than or equal to 0 question, so when we draw the u-shaped graph, it should be bigger than it. Okay? So the u-shaped graph is at 1 and 4. I want it to be bigger than it, greater than 0, so it's going to be this region out here and this region here. That means x is smaller than or equal to 1, x is greater than or equal to 4. Okay? Now, what I have to do next is, this is B, and the solution to A. So the solution to A is 2 is smaller than x is smaller than 3. That's all the numbers between 2 and 3. But you can see that B doesn't have any overlap. It's all the numbers that are smaller than 1 and all the numbers that are bigger than 4. This means that A intersection B has nothing in common, and therefore the answer is the null set. Okay? Next question here. Find the range of values which satisfy both inequalities. So we're going to multiply out this inequality, and then we're going to bring the x's over to one side. X goes over to one side, and the 4 goes over the other side. We're going to get 2x minus x, which is x, and 5. When the 4 goes over the other side, it's a minus 4. 5 minus 4 is 1. So the answer to the first inequality here is x is bigger than 1. The next, we call that the answer to set A, and now we're doing set B. We solve set B as we normally do with a reference number, x plus 2, x minus 3, less than or equal to 0. We draw our u-shaped graph where it hits the axis at 3 and minus 2. 3 and minus 2. Draw the graph there. Okay, what we're going to see now is it's less than or equal to 0. Look at the less than or equal to 0. So this is above the axis, greater than, equal to, and now it's less than. So we're looking for in between minus 2 and 3. So it's going to be minus 2. Now that's a minus 2 there, so that's a minus 2, less than or equal to x, less than or equal to 3. Now what we want is an answer that obeys the red answer and obeys the black answer. Now minus 2 doesn't obey it because it has to be bigger than 1. So it starts at 1 now, because minus 2, minus 1, 0, they're all too small. So we need it to be bigger than 1, but smaller than 3. So it's all the numbers between 1 and 3. So a way of writing that would be 1 less than x, less than or equal to 3. Okay guys, and that is the end of our maths class there today.